SAN technology and communications. The storage area networks and the understanding how the server communicate with the storage systems in a data center. The storage network are specially designed to support the high speed communication between the servers and storage devices. In this enterprise environment, the performance and reliability are extremely important. So that is why the dedicated storage technologies are used nowadays. So the traditional storage network, that is, we can say that traditionally the data center use the storage area network, or we say the SAN. So SAN is designed to transport the SCSI commands. Okay, SAN is generally designed to transport the SCSI command between the servers and storage system. SCSI stands for Small Compute System Interface. It is a standard protocol that is used for the communication with the storage devices. In most of the traditional SAN environment, SCSI commands are transported using the fiber channel technology. Why fiber channel? So there is come very important question. Fiber channel becomes the popular because it provides the high performance, very low latency, reliable block level access, and dedicated storage communications. Okay, so these are the benefits. That is why we prefer the fiber channel. So unlike the normal Ethernet network, fiber channel is optimized specifically for the storage traffic. It generally ensures the predictable performance and minimal delay, which is critical for the database and enterprise application. Okay, so what happened in traditionally, server sends the data through the fiber channel switches to the storage area. So this setup forms the SAN infrastructures. Okay, there are some newer technology now. With the growth of the IP network, we know that new technologies were introduced to carry the storage traffic over the standard IP networks. So these technologies are standardized by the Internet Engineering Task Force, that is IETF. So there are two important technologies. That is ISCSI, that is stands for Internet SCSI. It allows the SCSI commands to be carried over the standard IP network. So instead of using the dedicated fiber channel cables, storage traffic can travel over the regular Ethernet networks. So, but obviously this reduces the cost because no separate fiber channel infrastructure is required for this, and existing IP network can be used. So however, the performance depends, but obviously it depends on the uh, network design and bandwidth again. Now what is a FCIP? That is a fiber channel over IP, internet protocol. Okay, so FCIP tunes the fiber channel traffic across the IP network. In simple word, we can say that the fiber channel remain uh, the internal storage protocol. The IP network is used only for transporting it over the long distance. FCIP is commonly used for the data center replication. This FCIP commonly used for the data center replication, disaster recovery, and connecting to the remote SANs, whatever storage area networks we have. Okay, here we have two more concept, that is the SAN and NAS, which generally the SAN generally support the block level storage and NAS file level storage. So let's understand the another important concept. So in data center, storage can be provided in two main ways. First one is a SAN, that is a block level storage. Okay, in this storage is presented as a raw disk block. The server control the file systems and high performance. For example, This is suitable for the databases and enterprise application. This SAN technology for specifically block level storage. Um, the another one is a NAS that generally supports the file level storage. Okay, uh, in NAS we say that the storage is provided at the file level, and it generally access using the protocol like NFS and SMB. This file system is managed by the NAS device itself. Okay, so server access this file directly instead of raw blocks. So NAS is commonly used for the file sharing, backup, share folders, and media store. Okay, so what is the major difference between SAN and NAS? In a SAN, it supports the block level storage, and in a NAS, it stores the file level storage. So SAN gives the raw disk access, and NAS gives the file based access. So this is the major difference between these two technologies. Okay. Okay, let's understand the another important concept, that is a data center transport layer. Uh, uh, Also, it's important in modern distributed data center environment. Okay, so what is the data center transport layer? We can say the data center transport layer, which include the technology that requires to enable the communication between the geographically separated data centers. So in simple words, we can say it connects the multiple data centers located in a different cities, regions, or you can say the even different countries. So it acts as the backbone that allows the distributed data centers to functions as a unified systems. Okay, the question is like here, why we need the distributed data centers? So we can say that the organization deployed the distributed data centers mainly for the three important reasons. The first one is the disaster recovery, second one is the business continuity, and third one is high availability. So let's understand with a simple example. So if the primary data center in Mumbai fails due to the power outage, or natural disaster, or any network failure, the organization must continue provide the services. So in that case, the traffic must be automatically routed to the another data centers, let's say in Pune or in Delhi. So this is possible because the data center transport layer. This is popular because data center transport layer. So what is the main responsibility of transport layer? We can say that uh, the data center transport layer support the communication for the two major purpose. Uh, like uh, that's routing client to server traffic. Okay, where and the second is the communication between distributor server farms. Okay, communication between distributor server farm. So we will discuss these things, no issue. Okay, uh, okay, so routing client to server traffic, when user access an application, their traffic normally goes to the primary data center. If data center becomes unavailable, the transport layer enables the traffic redirections, load balancing across the site, and seamless failure. So users should not experience service interruption. So this is ensures the high availability. Okay, and if you talked about the communication between the distributed server farms, so this is again another important function which enabling the communication between the server farms located in a different data centers. So this generally requires the remote mirroring, data replication, and clustered. So for example, if database is updated in one of the we can say the data center, the changes must be replicated to the another data centers real time. So this ensures the both the sites have the synchronous data. So in case of the failure, the secondary site already updated data and we can immediately take over of that things. Okay. uh, there are different technologies we use for the uh, this transport layer. Okay. That we discuss in next slide also. Also there are some importance like the disaster recovery, business continuity. Okay, so let's see the another slide. Okay, so data center transport technologies generally supports um, two major traffic categories. Okay, so in data center transport network, and let's understand why they are treated differently. So in distributed data center architecture, traffic is broadly divided in a into two parts, that is user to server communication, the first one, and second one is a server to server and storage to storage communication. Okay, so you let's discuss about the user to server communication. So let's first understand this. So this type of traffic includes the client accessing the web application, users logging into the enterprise system, customer accessing the banking and e-commerce platform. So this traffic typically travels over the wide area network. There are several technologies have traditionally been used for the VLAN connectivity, such as the frame relay, asynchronous transfer mode, T1 E1 circuits, Metro Ethernet, synchronized optical networks. Okay, let's brief understand their purpose. So if we talk about the frame relay and ATM, are the older WAN technology. This frame relay and ATM stands for the asynchronous transfer mode, are the older WAN technology that is used for the packet switching communications. And this T1 and or E1 circuits, so it's provided dedicated digital communication links. Okay, what is the Metro Ethernet? So we can say it provides the high speed Ethernet connectivity within the metropolitan areas. And what is the SONET? Synchronous optical network, that is SONET. So it is used for the high speed optical communication over the long distance. So this technologies ensures can reliability, access and application host in data centers. However, slight delay in user to server communication may be acceptable within a particular limit. Now let's discuss about the server to server uh, and storage to storage communication. Okay, so in this now this types of traffic is much more sensitive. It includes the data replications between the data centers, clustering between the application servers, database synchronization, and storage mirroring. So here the small delay can be caused a very serious issue. Okay, so for example, if database replication is delayed, the secondary data center may have the outage of data. So this can leads to the inconsistency and service failure during the disaster recovery. Okay, so there are different technologies we generally use in the this transport layers. So, because these are the strict requirements, specialized technology like we generally use over here. So the first one is the fiber channel. Okay, it is a high speed storage network protocol. It provides the low latency and used for the storage area network itself. uh, the second one is the ESCON and ESCON and FICON. So what is the ESCON? That is the enterprise system connections, and this is a FICON means fiber connections. So it is used mainly in a mainframe environments for the high performance storage applications and communications and reliable enterprise level connectivity. The last one is a gigabit Ethernet. It's obviously again it is high speed Ethernet communication. which use for the clustering and replications. It generally support the IP-based storage solution. So these technologies provide a very low latency, high bandwidth, and reliable block level communication. Okay, why this type of sorry, why this traffic is more sensitive? That is server to server and storage to storage traffic. It generally requires the continuous synchronization, accurate replication, and immediate failure capability. If latency is high, the clustering may fail, replication may break, the data corruptions may occur. So this is why this traffic is prioritized and engineered carefully. Okay, what are the key difference between these two categories? So we can say the user to server traffic, that is a WAN based, slight delay acceptable, and focus on connectivity and accessibility, whereas the server to server or storage to storage traffic, that is internal or inter data center, it external latency is really sensitive, and it requires the high bandwidth and consistency. Okay, so I hope you understand this supported transport technology over here. Okay, the last one, that is the optical transport infrastructure in data centers. So let's understand this for also. So which is play a critical role in connecting the distributed data center over the long distance. Okay, over the long distance. So to carry different types of traffic, such as the user to server traffic and server to server replications traffic, high speed metro optical technologies are used. Very simple. So there are three major technologies, that is a dark fiber, the first one is a, second one is a coarse wavelength division multiplexing, and second one is a dense wavelength division multiplexing. Okay, uh, let's see what is a dark fiber. So dark fiber refers to ensure the optical fiber that organization lease or own. So it provides the direct physical connectivity between two locations. So since the organization control the equipment on both ends, it's often find that the high bandwidth, flexibility, low latency, full control over the network designing. So it is a ideal for the connecting the nearby data center within a city. Okay, what is a CWDM? CWDM stands for the coarse wavelength division multiplexing, which it allows the multiple signals to be transmitted over a single fiber using the different light wavelength. It is a cost effective, suitable for the metro distance, and is used for the what we can say the moderate bandwidth requirement. Okay, the last one is the DW1, DWDM, that stands for the dense wavelength division multiplexing. It is more advanced than the CWDM. It supports the large number of wavelengths. It's much higher the bandwidth as compared to CWDM, and long distance communication. So DWDM is commonly used for the intercity or the long haul data centers connectivity. Okay, here we generally use the layer 1 transport technology. So all these technologies provide the layer 1 uh, transport. So this means they simply carry the signals at the physical layers without modifying the high level protocols. Okay, they can transport the fiber channels, Ethernet, EP traffic, and storage replication traffic without any kind of interfaces. Okay,